Hello and welcome to this demo on unattended automation with Orchestrator folders. Now in today's video, we'll first learn about setting up unattended robots in Orchestrator folders. Then we'll get to run background and foreground jobs with the unattended robot that we're setting up. And while doing all of this, we'll also cover the concept of job priority. Now a word about background and foreground processes before we begin. A background process, also called a headless process, refers to a job that runs without interacting with any sort of UI. When built in UiPath Studio, a process needs to be set to start in the background. On the other hand, foreground processes use the graphical UI. Based on this differentiation, a foreground process can run in parallel with one or more background processes in attended automation, for example. And we'll now see how this works in unattended automation scenarios involving Orchestrator folders. Let's start with the setup needed. One point to emphasize right from the beginning is that unattended robots do not exist as separate entities. They're a combination between a user in Orchestrator and a machine connected to Orchestrator through a machine template. From this perspective, a better name for a robot is execution slot. But this doesn't sound too exciting, so let's stick to robot. To make the setup simple, one setting is enough: the automatic robot creation, which can be activated at user level. This allows the use of runtimes by that user to execute unattended jobs on a machine. In Orchestrator, we need to define at least one machine template, which we can then use to connect physical or virtual machines to Orchestrator. It's time to see all of this in action. Let's first navigate to Tenant and then Users. We have an Active Directory user already added in Orchestrator, the demo user right here. The Active Directory integration is another step towards the simplification and scalability of unattended and even attended setups. At tenant level, our user has the Allow to be Automation User role. If we navigate further to the Unattended Robot tab, we can see that the automatic creation of an unattended robot is enabled, and all of the other information needed were added here: domain username, credential store used, and password. Let's navigate to the Machines page, where we've already created a machine template. And for this machine template, we've allocated 5 unattended runtimes or licenses. This is the maximum numbers of jobs that can run at the same time on a machine that uses this template, provided that there are enough licenses available on this tenant. From these 5, there can be a maximum of 1 foreground process at any time. Remember the number of runtimes that we have allocated: 5. It'll be important later in the demo. One important mention here before going further: the ability to allocate more than one runtime and to execute several processes on the same machine is applicable only for Windows Server machines. Let's now navigate to the Folders page. We've created a folder for our demo today called Unattended Headless. Keep in mind that both the user and the machine template need to be added at folder level, and in our case, you can see that they are. We also need to make sure that the users have at least the Automation User role assigned at folder level to be able to run automations. It's clear that this one does. Now, before running the automations, let's take a look at the processes for a moment. We'll navigate to our folder from the left side menu and go to Automations. This will open on the Processes subpage. Here we have 2 processes. One is headless and will run in the background. The other one is foreground, so it will interact with graphical user interface elements. Each process has a specific icon that we can use to identify its type. One last thing to notice on this page is the priority set at process level. In both cases, it's set to normal. This will be important a bit later. Now, let's run some jobs. We can do this without going to the Jobs page by clicking this button here. Start a job. We'll start by running the process which requires interaction with graphical user interface elements. The job priority is inherited from the process that we're using, but it can be changed from here. We'll leave the fields as they are and execute the process for a number of 5 times. Let's click on Start and see what happens. 5 jobs have been created, but only 1 is running. The other 4 are pending. This happens because at the moment, although we have 5 runtimes or licenses, we only have 1 unattended robot running on a single machine. And since the jobs require UI interaction, the jobs will run in a sequential mode. As soon as the first one finishes, the second one starts. Alright, let's now create another set of jobs, but this time let's select the headless process. And let's also change the job priority to high. Then change the number to 5 and hit Start. There are several things to notice here. 4 of the 5 jobs involving the headless process started right away, and the last one of them is in pending. This is due to the fact that a job for the UI-dependent process had started before the 5 headless jobs were ready to start. At this point, all 5 runtimes are being used. As soon as the UI-dependent job ends and a runtime is being freed, the last job for the headless process starts. This happens because it has higher priority than the remaining one for the UI-dependent process. The last job from the 2 sets, a UI-dependent job, starts as soon as the headless jobs were completed. And the rule stays, maximum 1 job requiring UI. Alright, this concludes our demo on unattended automation with orchestrator folders. Let's briefly recap what we did. We first set up a machine template and an Active Directory user. We've added them to a folder and ran 10 jobs, 5 using a headless process, the other 5 using a foreground process. We've also set the headless jobs with high priority. And that was all for today. Thanks for watching.